Good day everyone. Today I will discuss the CNC Machining Part 1 Introduction. Introduction. Definition. CNC computer numerical control refers to the method of controlling a machine tool or the machinery process by means of a computer. So unlike our conventional machining, coded numerical instructions are inserted into the CNC programming language. So brief history. 1942, Bentex Corporation, a USA helicopter blade manufacturing company, needs three-dimensional cam parts, so coordination of movements is necessary. In 1947, John Parsons, using punch tapes, is able to control simultaneously axis movements of a machine. So this is in collaboration with MIT. In 1953, numerical control terms appear at MIT. Then in 1960, adaptive control term appears at MIT. In 1970, computer numerical control CNC is created using a microprocessor's origin. Then in 1980, direct numerical control or DNC is possible. So a large number of machines are controlled by a computer at that time. Introduction. So I have to explain here the CNC block diagram and the different loop controls that we are used for CNC machining. So for the CNC block diagram, we have here the input device. So we program first using software, or it could be directly inputted using the computer interface or HMI. Then we have here the machine control unit, which display the unit. Then the data that we entered will go now to the driving system, like the motors. Then we'll proceed now to the machine tools, which will be converted from your program to actual CNC movement, the X, Y, or Z axis. Then we have here the feedback device. So this is very important for sample safety, and for the programming we have some limits to put in the program that the machine will follow. Then again, we will feedback the position to the display, and we can see it's in the right machining area in materials during the CNC machining. And for the loop control types, we have here the open loop and the closed loop. So the difference of the two is that in closed loop, we have here a feedback. So for example, the CNC receiver here will receive the feedback from the the speed, the feed, and the torque, and the force here in our machining program or actual machining area here in the bed. Okay, we're in open loop, so when you program, so just follow your program, and the machine will move based on our CNC program. CNC machine tool description. So for feedback devices, this is an encoder. It's a sensor for converting rotary motion or position to analog digital signal. We have two feedback devices here. The number one is the absolute rotary encoder. So here, every position of an absolute device is unique. The desk has many circular tracks. The higher the number of tracks, of course, the higher the resolution. So these devices do not lose position when power is removed. Homing sequence not needed on startup. They do not accumulate errors. So this is not affected by noise signal. They are more complex and expensive. So on the other hand, the incremental rotary encoder, the feedback signal is always referenced to a start or home position. They need an external processing of signals. In the event of a power failure, it must be reinitialized. So they are susceptible to noise, those errors, then they are simpler and cheaper. So they have both the two have the advantages and disadvantages. Okay. Linear glass scale encoder. So this one measures directly the position of our linear axis, high positioning accuracy, high permissible transversing speed, and it can correct Next, errors. Example, the positioning error due to thermal behavior of the recirculating ball screw, reversal error, and kinematics error through ball screw pitch error. Let's move now to the advantages and the disadvantages of the CNC machine. For the advantages, it is high repeatability plus high trueness equals to high accuracy. More complex three-dimensional geometries, better quality, higher productivity, greater safety and lower operation qualification, greater flexibility to part changes, and can minimize human errors. So aside from advantages, of course, there is also the disadvantages. So number one, this is higher investment cost, higher maintenance cost, time-consuming setup, and of course, training is needed for CNC programming. Types of machines. We have turning centers, milling centers, machining centers, drilling machines, grinding machines, ED machines, laser cutting machines, and so on. So any conventional machining before that have or use CNC software and programming, so this can be classified as CNC machines. And we have some example of CNC manufacturers, so it can be seen here at the bottom. Axis nomenclature. So here we can study the different axes for our CNC machining. So for lathe machine, we have only two axes, the Z and X axis. For milling machine, example, the 3 axis, we have 3 axes. And for advanced machining, you can have 5 to 6, 7, 8, or 9 to higher, many more axes. Okay. So we can use here as example, as a guide, our hand. So using our right hand. So when we have to position our hand like in the pictures, the middle finger is the Z-axis, the index finger is the Y-axis, and the thumb is the X-axis. We will discuss here the reference system. So you can see here the different position and starting points that we will use in our CNC machining setup. So here the M is the machine 0, okay, the machine 0 from the machine specs, and we have here the part 0. So we will set this one for the setup of our workpiece. So again, this one depends on the sizes, so we can reprogram this in our CNC programming. Then R is the machine reference point, so from the spindle here. Then X and Y, Y and W, or any others format, this is the coordinate of part 0. Then X and R, so coordinate of machine reference point, or the ref value. So M by definition is the machine 0 or home. This is set by the manufacturer as the origin of the coordinate system of the machine. So W is the part 0 or point of origin of part. This is the origin part that is set for programming the measurement of the part. So it can be freely selected by the programmer. R is the machine reference point. This is the point on the machine established by the manufacturer around which the synchronization of the system is done. The control position the axis on this point. CNC machine setup and operation. So number one, we have the pre-start. Check coolant and air supply labels. Ensure work area is clean. Then of course we have power on. Then find machine 0 or home. So after that we need to load the tools. So fill the tool carousel. So it depends on our programming. We will set the parameters for that, for the toolings. Okay. Number 5, set machine reference. So define tool length and radius offset. Here we will measure the tool length and the radius offset in your setup. So meaning different tools will be set up accordingly. in our machining. Okay. The number 6, set part 0. So once the horting wheel device is properly installed and aligned, set part X, Y, and 0 dayton. So if everything now is okay, the clamping and the dimension, the setup for referencing, so we can now set the part 0. Okay. Next is the load CNC program. So if we use CAM software, we can load the CNC program, but if not, we can program manually in the machine interface. Okay, then we can simulate. If the program is okay, then we can now run the program. So after finishing the machining, so we can clean the machine and power it off. That's the end of our part 1 introduction for CNC machining. So I will upload again next time the detailed lecture for reference system for the part 2 of this lecture. Thank you.